I want everyone to take a deep breath with me. Now blink your eyes as fast as you can. Every time you breathe or even blink, you're changing the environment of your cells. Just like when our environment changes from summer to winter and we adapt, so do our cells. If your cells fail to adapt to their changing environments, devastating consequences can arise, including the development and progression of cancer. In 2018 alone, an estimated 1.7 million new cases of cancer will be diagnosed, while approximately 600,000 people will die from this disease. Therefore, studying how environmental changes affect a cell and its fate is crucial in the ongoing fight against this disease. One way cells adapt to changing environments is through a physiological change known as cell stiffening. I like to think of cell stiffening like the Roman army interlocking shields. When under attack, the Roman soldiers would stiffen up their shields and stay together. In the cellular context, stiffening functions in a similar manner. When a cell experiences a force, it reinforces its attachment to neighboring cells and the underlying tissues. This enables the cell to resist the force, or the attack, and continue to provide protection to the organs they surround. Just like the Roman army with its many different soldiers, the cell stiffening process requires many different players. In this case, many different proteins. My thesis focuses on an important protein in the cell stiffening response known as PAC2. When a cell experiences a force, PAC2 regulates cell stiffening via two distinct mechanisms. First, PAC2 helps the cell balance its energy intake and output. Through this control, the cell is able to direct its energy towards processes that promote cell stiffening. Second, PAC2 determines whether a cell lives or dies in response to force. If the cell is healthy and stiffening properly, PAC2 promotes its continued survival. On the other hand, if the cell is unable to stiffen, PAC2 signals for its destruction. Just like the Roman army general evaluating the status of his soldiers, PAC2 determines whether a cell can continue functioning or if it's time to replace it. Understanding the role of PAC2 in cell stiffening and cell adaptation to forces is a critical step in beginning to deduce the basic processes that go awry in disease states like cancer. So the next time you take a deep breath or even blink, think of all the things that your cells are doing to protect you.